Start. So we're recording this session so everybody has access to it later. I just want to say hi, everyone. Welcome to the Sporlan Experts webinar on the R290 propane systems. Quick housekeeping. The chat's turned off for today's session, so please use the Q&A panel to send your questions. We'll work on them as we go. Our co-host David's already queuing up a few, so feel free to start submitting now. You'll receive a follow-up email after our webinar concludes today with the reference materials that we used. Before we dive in, let me introduce our speakers. David Thomas is an applications engineering technician focused on our legacy products. He holds an associate's degree in engineering sciences and mathematics and is currently pursuing an electrical engineering degree through University of Missouri St. Louis and Washington University's joint program. We're also joined today by Paul Chambers, our applications engineer, who emphasizes on training. Paul earned his Bachelor of Science in Engineering Technology from Pittsburgh State University in Kansas, where he dual majored in mechanical engineering technology and automotive technology. All right, let's get started. David and Paul, the floor is yours.
Thank you, John. Share my
Welcome.
here. Share the slides here. Thinking. All right, so you guys should be able to see the slides. So like John said, or might have said, we are going to be talking about propane and propane accessories. So, David, what do you know about propane?
We could buy it at the gas station for some grilling. So outside of that, I've never utilized it as much in the AC application. Could you tell me a little bit more about that, Paul?
I sure can. So going into the use of it as a refrigerant, I'm going to start out by comparing it to some other refrigerants we might know. So I want to compare it to R22. Some people might say that R22 is a bit antiquated. We've kind of done away with it, but I think it's a good baseline. A lot of refrigerants that we use in the industry today have been installed as a 22 replacement or a replacement of a 22 replacement. So if we can look at it in comparison to that, it's going to really paint the picture of how it's useful, how it operates, and how it might be different than some other green refrigerants out there. So we'll do a brief picture on R22 and its regulations. That's not really what we're here to talk about, so we won't spend too much time. But it was phased down and out. We saw a limited production by you can't install new systems, can't sell new equipment for the R22. And then we, starting in, let's see, 6 years in January, we have not been able to import or manufacture. So it moved out. We all know that. And we saw replacements for it. So in the AC industry, we saw 410A, we saw R32 after 410A was going away. We saw 32 and 454B depending on the application or the manufacturer. And then in the refrigeration application, we saw 404. That was almost in conjunction with R22 actually, because that was for the going away of 502. Both 404 and R22 went away, and we see 448. And then now that that's also being taken out, and we're seeing a few new contenders. 454C seems like it's probably going to be the strongest contender in the refrigeration replacement. So a lot of numbers there. Main story is we see this kind of replacement after replacement. Started out for the issue of ozone depletion, and now we're moving on to the global warming potential. These are terms we've all been hearing in the industry. That none of that should be new. And we'll look at some of those levels later as far as how do they compare with ozone depletion or global warming potential. And then there's the regulation side for R290, and that's actually what we're here to talk about today. So it was, interestingly enough, used before R22, and in some ways R22 was an R290 replacement. I think some people see it the other way around. We used R290 propane and found it to be flammable, and then thought, oh, can we get it done with something that's not flammable? So that's when we gravitate towards those HCFCs that have been long since done away with. More recently, acknowledging the flammability, but also acknowledging the good refrigeration properties, UL has written some standards. So we got those UL 6335-2-40, and then there's -2-89, and those kind of spell out how we can use them in the industry. Those get adopted then by building codes. And the building codes are what actually say, hey, this is factory systems only. You can't, in the US, you can't be making field installed R290 systems. That is the current state in the US. And I want to stress that because there are places, other countries, where you do see some field installed or different applications of R290. Um,
So rather not stamp of approval, but guardrails.
they're guardrails, yeah.
Yeah.
And then right now guardrails move, right? Regulations change, especially as new technology becomes available to control those refrigerants. In those factory-made systems, you have a charge limit. We're all aware of that. And so they were initially set around 150 grams. That's kind of small. Not a whole lot you could do with that. You know, you're doing some small systems. And then recently the EPA, with the SNAP ruling and the UL, they moved those charge limits up. So we see that on a closed case system, you got doors on it. There's a little bit more concern of refrigeration buildup and reaching that lower flammability limit. You'll see 300 grams for that and a 500 gram limit for an open case system, like an open deck. And that is actually a significant amount of cooling. I mean, for those of you like me who might not be on the quick for the grams to pounds, that's a little over a pound of propane refrigerant. And you can do quite a bit of cooling with that. I mean, we're talking, you could, tons or tonners, you're actually cooling case. And that's why we do see these standalone cases coming out that are 290 and well another one would be another A3 would be the 600 isobutane and stuff like that.
But this is where you don't see like large capacity systems.
No, so yet we don't
Due to the quantity.
due to the quantities
Yeah.
we don't yet in the US see the use of R290 is like definitely not a rack system. You're not
Yeah.
seeing 100 pounds. You're not seeing but a lot of that has to do with coming back to the building code. So if we were to look at in other countries, we do see it used in other applications, and we'll talk about some of those applications here a little bit later. So we'll look at a quick snapshot of. Now we're going into the performance regulation. That's I'm sorry to everybody. It's been so little time on everyone's favorite topic of regulation, but now we'll move on to performance, which I know is sadder. So when it comes to those just snapshot performance, we're going to look at it on AC first.
Mhm.
And like as we said, we had the 410A, the 32, the 454B. And on the left, we have this, I find pretty interesting unit or measurement called the NRE or net refrigeration effect.
How do you calculate that?
Yeah, so it's going to basically be the delta enthalpy across the expansion valve or device and coil. So down here we'll see it says 9-degree fluid. So you could change this a little bit depending on your set points. We've chosen 9-degree fluid coming in, liquid coming in, and a 20-degree saturated vapor going out. And so if you imagine that going through the system, the enthalpy, the BTU, the energy per pound, that's what we're measuring here. And each refrigerant would have a different capacity for doing that per pound. We can see R290 is actually at 121. That's not quite twice R22, but that a lot of R22 replacements, are in that same lower NRE. And in these quick snapshots, there's a lot of information there. Not too much. Don't want to get bogged down in all those details, but we do see some interesting things like R290 is going to be as we know, it's a propane. It's a pure substance like 22, like 32. That means no glide. So we see glide in 410A. We see more glide in 454B than we saw in 410A. So those are some things to be aware of when you're designing a system. What do you want to work around? We see this A3 versus A2. So we've talked about that before. Always good. Just quick reminder, A is non-toxic, B is toxic. So ammonia would be a toxic. That's another natural refrigerant that you'd find that is toxic. And then the 123 or 2L that was added later is the flammability. So these A1s, 22 and 410A, so they're non-flammable. They do not propagate a flame. A2L that does propagate somewhat. And then A3, no surprise, propane is quite great at propagating a flame. You can cook some food on that. But the other thing I'd like to point out is this actual global warming potential. And in line with all these, we see this 3.3 is very low, especially compared to that 1800 we saw in 22. And if you thought that was high, the replacement for 22 in the AC systems was actually higher. So that's because we were doing it off of ozone depletion. So ozone depletion, that's bad. We move out for 410A, which has a lower ODP. And then we start to realize this other issue of GWP. And now we've gone down to R32 and 454B, which are significantly lower than these two, but still significantly higher than 290. So there is some, in the industry, we do look and there is some case that, well, maybe we want to future-proof this. If we went from this and we got regulated down, what if it gets regulated down again? What can we start designing for now that will be in there for a long time? Changing refrigerants is great for companies like, Honeywell and, Chemours. They don't mind that because that means they're making new stuff and we're buying it. But for all those manufacturers out there and technicians, we just want to, get on the right stuff and stay there for a while.
Okay.
A
What about
quick,
for the refrigeration side?
oh, for refrigeration side, yeah, pretty similar, but actually in some cases, more extreme. So same to at the beginning of 290 and R22, but then we'll see 404 and 448 and 454, which actually have lower NREs than 22, except for the 454C. So in this case, we are actually, a lot of the replacements were a lot worse of a refrigerant, or less, I say worse, less efficient of a refrigerant than 22. 22 did have some drawbacks. I'm not going to pretend. There are people out there who will say it was the greatest refrigerant ever. There were some drawbacks. That's one of the reasons we saw the introduction of 404 was basically when 502 was regulated out. You could use R22, but it had really high discharge temps, especially in those low temp applications. There were ways to get around that. One of them is to just switch refrigerant to 404, or you could use a nifty little valve like a Y1037 made by a pretty good company. I think you might know who made that.
We made it.
We made it, Sporlan. It's us, and that could help you control those discharge temps. So there were ways to do it either way. But we're gonna, like I said, we see the same example of not amazing NREs, and then we start to see high global warming potentials. We went from 18 to 39 this time, not climbing by 200, but over 1,000 points there. And then 448 didn't drop a whole lot. 454C now does get pretty low at 146. Yet again, another concern. And in the refrigeration space, we see people trying to go to CO2. Well, the concern there is that 146 was designed to get underneath a threshold of 150.
Mhm.
So when you're designed to get just underneath the threshold, there's always that remaining concern of, but what if that threshold moves again? Like you said, they're guardrails. Guardrails change. That's the kind of the nature of them. And I just want to compare really quick before we move on to some other parts of the performance now. These were some quick snapshots. We can look at things like, I want to compare the boiling points. And, they actually, like, critical point, they look pretty similar between 22 and 290, and a little bit more different than we see, especially on these glides, than we see to other refrigerants. So stressing, we'll move more into it, but stressing is a lot of weird similarities between 22 and 290. So we'll keep going down into more performance based now. I've got two graphs up here that I find interesting. Hopefully you guys will too. We've got the top one has R22 versus 290 as a pressure temperature curve. Anyone who's in the industry, we know that pressure temperature is the heart of diagnosing systems. It's the heart of the operation of the system. We've got, we send out how many PT charts for different refrigerants. And on the low end, low temperatures, we see that R290 and 22 are almost identical. Once you get into those higher temperatures, we do start to see those pressures differentiate a little bit. 290s being a little bit lower, not too bad. But then the bigger difference is in the density. So there's 2 lines per refrigerant on that graph. That being for the liquid density and for the vapor density.
Mm.
The liquid density of R22 was actually kind of high compared to other refrigerants, especially compared to 290, compared to propane. And so it could do a lot more because we talked about per pound, right? That was the NRE was the BTU per pound. So it wasn't that efficient of a refrigerant, but it was so dense of a refrigerant that the efficiency kind of made up, right? Because there's a more pounds of R22 for the same volume. So if you look at all those things compared, the slightly lower pressures, the big ones are the NRE and the densities, which then actually translate to flow rates because you have to flow so much to get that, pounds per volume per, you get a flow rate. Well, they actually kind of cancel each other out a little bit. So that all of a sudden, R22 and R290 end up being within about 2% of each other thermodynamically, operationally, within about a couple percent of, of each other.
So Paul, I can't get any more R22. I could just take 290 and replace my system, right?
You could you could, but if you were recommending that to me, I would run away. That is a terrible idea. For a lot of reasons. The other bullet point on this slide is that it is a very useful refrigerant. Yes, it is incredibly similar to R22. If you were to look at piping diagrams, you could run it the exact same as historical refrigerants like 22. It has no functional difference like you might see in ammonia or in especially CO2. You know, CO2 is a great natural refrigerant, but you get those high pressures. So this has a similar operation to R22, but it's highly flammable. And I would like to point out, among all the other reasons that you should never, 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 I repeat, never put R290 propane into a system not made for propane, like a 22 system, is that most of the time that you're taking a refrigerant out, it's because you've got a leak somewhere, and this doesn't smell anything. So we've all, like we said at the top of the webinar, we use this for food, right? We're all kind of aware of propane. We've been around it, and it kind of smells like rotten eggs, except for that it doesn't actually smell like anything. The propane that we use to cook with has a odorant agent put into it. That's what we're smelling when we smell our, when you turn on your grill and you're trying to light and your lighter's dead because it's been outside all weekend. Uh, that that smell you're getting is not actual propane. So the concern the is not just that it's flammable, but it's an odorless flammable refrigerant. So that is a good thing to be aware of while we're working with it. But yes, it is important to also understand that very similar and functionally, if you understand the properties of a traditional AC or refrigeration system, moving into R290, moving into propane, you're not going to have to learn a lot new, uh, operational things. You should just learn some new safety measures. So,
With such great performance, what applications do we have to offer for this?
yeah, that's a great question. So we do have a lot of offerings, and we'll go into what I would consider kind of the heart of a system. Obviously, you got the compressor, get the pressure up. You have to have the expansion device. Um, and the flagship one that we're going to basically put out there would be the NX. So this is a wonderful thermostatic expansion valve. We call that a TEV here. Some people call it a TXV. I may have called it that in a previous life, but now that I wear a Sporlan shirt, I say TEV. And it is a great compact valve so that it fits in a lot of cases. I've installed it in some cases. It's really easy to get in there. That comes internally and externally equalized. A nice thing about the compact format is also that it has a really small internal volume. So we talked earlier about charge limits for propane. Well, if you add a larger valve, that's more holding capacity in the valve. That affects more of the charge that you have to add to the system. This would affect that charge very little. MRP of 700. Every single one is adjustable superheat by design. You can have strainers installed. They stainless bulb and cap tube. I like those. A lot of people like those. And then fractional tonnages from about quarter ton to about 8 ton. So pretty wide range. We do have valves going lower than the NX, lower than a quarter ton. EF would be a good choice there if you're looking for that. But just an important note that we have a great valve there. We have distributors. You always need a distributor with a valve, or almost always. I mean, if you're going to a single circuit, maybe not, or a single line. But those are solder joints, so they pair well with our TVs, our NX, and our EF. And then if you want an electronic valve, we are in the process of seeking approval for the SCR valve through UL. So, but we might have other ways of controlling. There's more than just the expansion. There's other ways of controlling the refrigerant. So that might be the solenoid right there.
So coming prior to our TXVs, functionally just an on-off for our refrigerant. We primarily are going to support the E-series solenoid valves, primarily the high pressure model. And the advantage of this one is that you can braze it in without disassembly. You are going to have to use that HP model in the R290, as the regular E series is only 500 MRP. They're hermetically sealed. You're and because R290 is going to be a relatively low capacity, you're maybe going to be looking at anything from like the E2 to the E3, and as more regulations change, potentially you can get to a little bit higher, but as for now, it'll be those lower ones. Um, so yeah, you can mount it in any orientation except upside down. We never approve of that. But other than that, yeah, prior and then coming before the solenoids, we also have catch-alls.
Yeah, so the catch-all filter dryer is what that's our term, is the catch-all for it. These are wonderful things. They remove moisture, they remove foreign matter, they remove acid. And I think in a lot of instances, I see people think of these as kind of a repair method. You know, after you've worked on something, it's good to install that. Or maybe if it's been open for a long time, you know, you've been working on it, it's good to install that. I mean, and then we do say it's good, you know, after a breakdown or burn at it, you know, it removes that sludge, it removes that varnish, but it's also good in a fresh application. So we see in a lot of these, especially low temperature applications, you get these small thermostatic expansion valves. Or while I'd like you to buy a valve, some people do use cap tubes, and that's a way to get an expansion. Those are very prone to clogging, especially and once again, people think brand new system's clean. Brand new system also has wax in it. That's just from the manufacturing process. So having one of these upstream of your expansion device is very helpful, especially in those low temperature applications. And we have special models. We have, so all of these are hermetically sealed, or both of these models are hermetically sealed. We have also the HH. So there's different, basically
Cleaning.
different notes on them. So the HH would be for a high wax. And then we have one for a dash cap would be for a cap tube system. So if you are using a cap tube, we have special filter dryers that are designed to go to solder onto those as well.
Very nice. And obviously, maintaining a system requires you to take in as much information as you can. And our CLs, our moisture and liquid indicators, will let you do that by visually looking directly into the refrigerant, and so you can see a full column of liquid. Um, and and we also have an indicator paper in there, and that paper was going to react with any moisture, and it'll stay green when it's dry and yellow when wet, and you'll be able to distinguish what you're going to need to do to your system to continue on. Paul, when you buy this, what is the indicator paper going to look like?
Well, that depends, and I like that you asked that. It's something I have had a lot of people ask me or come to me, "Hey, I got this new one, and it's already bad. It's already wet." And so this is as you mentioned, it's a accurate piece of paper. It's calibrated piece of paper that does read out the moisture content, and the moisture content in the air is not zero. So it might have sitting on a shelf, gathered up some moisture, and gone yellow. That doesn't mean it's not a one-time use. This is an accurate live read of your system. And so if you put it back and you have a clean, dry, and tight, which this is good for making sure that your system is clean, dry, and tight, um, it should go back to green. And if it's not going back to green, it's most likely still got moisture on it. So if you pull one off the shelf and it's yellow already, do not worry. Just get it in a vacuum and it will turn back to green.
Awesome. Yeah, and then this is also going to be offered in a Zoom lock method, Zoom lock compatible method, and so we'll have um, all these different Zoom lock fittings, and Paul might be able to tell us a little bit more about that.
Yeah, so Zoom Lock, if you haven't heard of it, it's a flame-free refrigerant fitting. I have to say that a little bit slower. I don't want to speak somewhere. It's very easy to install. They come in a range of sizes from quarter to inch and 3/8, rated to 700 psi. I know that when I used to give tours of our facility, I would show these things under burst, and people are always impressed. They hold quite a bit of pressure. Um, and then another nice thing about them, especially if you're working on something that's flammable. So big selling points to this is like if you have trouble getting into it, it's a tight space, so you're going to burn something behind it. Let's say you're in a case, or like where you're trying to braze or run in a fitting, or you have a hard time getting a hot water permit because no one wants to shut down the facility. But another thing that we've run into is sometimes you don't want to get it in because you're kind of worried about the other flammable things that might be in the area. Like you've been working on propane. You've got the system isolated pretty well, but you don't really want to take a torch around the propane system. Can't blame you. This would be another option
Agreed.
for working on a propane system, working on a flammable scenario without a flame. So really, there's a lot of options, and there's similar options to what you'd see on the on a regular system. Um, Once again, we're having to just lean more on the safety rather than the change of like you would see in CO2. And I mentioned earlier, versus CO2 and how you see it in other applications. One place you might, it's not in the States, so we're getting a little bit off topic, but I think it's interesting to mention because it is changing here in the US. So one place that you might see this outside now, because we kept talking about it's inside its building code, is that where we do see it in Europe is that you could have an R290 system condenser. So this is the, you know, entirely outside outdoor system. You don't have to worry anything about the flame as much. And you're going to have a secondary fluid. So you could have a glycol, um, you could have a CO2. So we've seen that actually over in Europe. You have a R290 condensing unit with a CO2, pumped CO2. You could do a pumped liquid CO2 for the medium temp. You can do a little bit of expansion on the low temp. And so something to be aware of as our regulations change, we're updating, UL's always updating their standards, that this could be changing, and we are preparing for that. So, we mentioned the approval of the SCR. There's definitely applications already in the States where you could use that, but we have more offerings that are kind of not the US is not quite ready for them yet. Those larger SCR valves and some larger valves that you wouldn't really use right now. The E series, as he mentioned earlier, we kind of focused more on the small size of the E series valves because you're not going to be using a large E series valve, most likely on propane in the US right now. We are prepared for the scenario where we can use larger and larger systems of propane in the US.
Right.
So we talked about a lot of products. If you had questions on any of those products, there are a few places you could go.
You can go to me, as you can reach me by phone, email, or you can reach out to our literature page, and we have a bunch of bulletins talking about our R290. We have dedicated ones and individual ones.
Yeah, so a lot of what we had was off of a catalog called R290 catalog on the Sporlan literature page. Great place to go. And I've also just listed bulletins here. All of this is on the Sporlan literature page. All of it is David is aware of all of this, and he's on our tech support team, our applications team. So very capable of answering your questions, helping size things. When it comes to sizing as well, we do have a virtual engineer page where you could help size this. And generally speaking, if you can select R290, you can see, hey, I want to go get a valve.
If it says R290, then yeah, you're good to
go.
Good to size it.
Good to size it. With that, we'll move on to some questions. So
yeah, let me look over some of these and see. Yeah. Actually, earlier we spoke about this, but we can just reiterate it. Can you use R22 thermostatic expansion valve in R290 propane system?
Absolutely, you can. And so we mentioned two specifically. We mentioned the NX and the EF. Those are ones that we like, but there are other ones. So let's say you're you're a technician, you're out there, you don't have either of those in your truck. Well, all Q and BQ variations, good to use. ER, SR, safe. EBF, SPF, safe. EF, as we mentioned, and then O valves. All of those are actually already approved for R290. So not only can you use them, we do encourage it. It's a great thing to do. And there's a lot of options for it.
Yeah, so whenever they're looking at putting something in from the R290 system from R22, you'll see the refrigerant code is going to be V instead of anything else. So yeah, that's what they'll be using.
Yeah, and that points more to the
just existing.
The similarities that if you were sizing it, we historically would have sized the R22 system with a V, that would have been the nomenclature choice for an R22 system,
which will umbrella down,
and that will cover R290 because it is so similar.
So it's also got a question for propane use in commercial applications.
Yeah, so that is looking at propane versus propylene. So that has to do with why is propane used for commercial applications while propylene is used within the petrochemical industry? There's a few reasons, and I'm honestly there's a better person for that industrial side that someone might be able to speak to. But yeah, uh, flammability would probably be a big concern there, but a big choice there. So flammability and building code would probably lean towards that. And then I almost don't want to. So yeah,
We
there's
will acknowledge.
there's one more question that we're going to cover, and it's is there an issue with virtual engineer?
And
It's
yeah,
been very slow over the past couple of days. And David, you've ended this couple.
No, it's all
recently.
good. It's yes. So if you just got off of this webinar and you're like, I'm ready to go try some R290 products on virtual engineer, it's gonna have some issues currently, but within we have some technical difficulties this winter, but hopefully by next year we're up and running in no time.
So it is running.
Yeah.
I want to point that out. So if you are in there, you're trying to size it and it's going really slow, it is actually working. It's not broken. We will acknowledge there is an issue with it. There's some heavy usage on it right now.
Right now it's being the traffic really high.
So
we're trying to up that bandwidth.
We're up in the bandwidth working on the server. If you've tried to use it recently, and I mean, it was taken quite a while, it is actually going faster right now.
Okay.
So have some patience. You might be able, if you're just trying to do, a couple pieces, trying to size a couple pieces, if you have some patience, it will actually work for you.
But if you're getting into any snags or difficulties, just feel free to call us at tech support or email us at technical support at parker.com.
These guys are just amazing at their ability to size and select things. So if you're on a quick, trying to get this done quickly, they will be able to help you as well. So with that, I think we'll move on and hand it back to John.
Great. Super helpful information today, guys. Appreciate it. I just want to thank everybody for joining us for our webinar today on propane systems and the products that work in them. We hope you found this information valuable. If you want to circle back on this information, we have recorded today's presentation, so navigate to the Sporlan YouTube channel and you'll find a library of videos highlighting our products, some basic and some advanced topics. Special thank you to our presenters, David and Paul, for sharing their expertise and insights. Remember, you'll be receiving a follow-up email with the resources that were discussed today, so keep an eye on your inbox. We appreciate your participation and engagement. If you enjoyed this session, we invite you to join us for our next webinar, where we'll be diving deeper into setting head pressures. Stay tuned to our social channels for the announcement and registration info. Again, this session was recorded and will be on our YouTube channel, where you can also view some of our video shorts and training. So thanks again, and have a great day.